Yo, what's up guys? How are we all doing this evening? Freaking lockdown madness. Doesn't stop me working though. Fortunately, one of the very few businesses that actually doesn't really get affected by world events at present. How are you all doing? It's a slightly earlier stream for me this evening. It's like 10:29. Hopefully it's not too late in your country. Yo, Mazda 2284, how's it going my man? The electric guy, 2:57 AM. You need to get some sleep my friend. Promo 130, base starlet, and I see Matt's up in the live chat. That's back in the day. That's some nostalgia right there from when I first started streaming. Okay guys, this evening for you, I am hoping to bang through some amplifiers that have been returned from Amazon. These are your cheap and cheerful, proper entry-level like pile of amplifiers. And we're going to see if these are simple fixes or not. Now, the majority of the repairs this evening are going to probably be Class AB amplifier repairs. Now, if you ask the majority of amplifier repair technicians whether they prefer working on Class AB or Class D amplifiers, you will find that the majority of them say, Class AB every day. For me, however, I'm the opposite. I freaking hate working on Class AB amplifiers. I learnt on Class D, I learnt on Brazilian amplifiers actually, which is kind of weird. Talk about start dropping the deep end, but yeah, I learnt mostly on Brazilian amplifiers and Class D amplifiers, so I understand Class D amplifiers pretty well, and I can usually make a successful repair given a Class D amplifier, with a few exceptions. With Class AB, if there's anything funky going on with the drivers, I'm not too good at it. I like following square waves through the board. I like following drive waves and looking at their shape to determine how healthy the amplifier is. With Class AB amplifier, you can't really do that. You just need to know how much current is passing through the drive transistors, and it's a little bit more complicated. But I'm hoping, considering these amplifiers that are coming in tonight are Amazon returned, these are mostly like kind of pretty new amplifiers, so they'll either be user error, the amplifier works fine, they just didn't know how to hook it up, or simple faults. The rest of the board should be fine. If there is a fault in here, it shouldn't be too complicated to find. So what we're probably going to be looking at tonight is mostly manufacturing defects, or just the user didn't know how to use the amplifier, so they probably work fine. I need to wear a mask. Actually, hey, I do have. How's about this for your ass? Wait, actually, how does this even go on? Hang on a minute. Wait, pretty sure it's that way. I don't think it works with my hat. I don't think it will work with my hat. Whoop! Hey, what the hell? This thing just fell off. Actually, I think that's meant to come off, maybe. Maybe that's just a protector. Yeah, please remove this part before use. Okay, thank you. And then I shove that on there like that. Oh, there we go. Yeah, pretty good. And then I guess this goes around the back. Pretty comfy. Alright, cool. Coronavirus certified stream. Wow. Nah, that's not what we're about in here. But it's good to know that I actually have this. I forgot that I had this. I might wear this out and about. That could be quite funny. Pop down to the shops in like my flipping mask. Right. Let's get started with this first amplifier then. So, like I said, these are all Amazon returns, and the brand that we're going to be looking at, these are all pile amplifiers. They don't really have a huge following for quality and stuff, but you know, they might be good value for money. We don't know yet. Haven't really looked inside one of these bad boys yet. So let's crack her open and see exactly what we're working with this evening. I've got mostly 4-channel and 2-channel amplifiers of this, and I will almost guarantee that the majority of people that just randomly bought these things from Amazon were trying to run subwoofers. Let's be honest, out of the, like, let's say you've got 10 guys that are buying an amplifier for their car, I guarantee you 9 out of 10 of those guys are wanting to buy a subwoofer amplifier. But the problem is that for some reason people buy like 4-channel and 2-channel amplifiers for subwoofers. Like they assume that, oh, the more channels it's got, the more power it must do, and they don't understand that bass is mono and you need a mono amplifier regardless of how many subs you're running. So I guarantee that most of these amps were bought for subs. You'll be surprised the amount of marketplace items. Actually, I'm just going to turn my microphone down in case it's clipping. I saw it might be clipping a little bit there. The amount of marketplace items I see, and the amount of eBay listing items I see that are like subwoofer packages, like, you know, a sub in a box with an amp like screwed to the back. Most of the time, the amp that's screwed to the back is a flipping 4-channel. Like, what are you doing, bruv? Okay, so yes, as we can see, we have a really cheap basic Class AB 4-channel amplifier here. This is the same type of circuit that would date way back to the 90s. Not much has really changed on here. Let's have a little cheeky zoom in and see what it is we're working with. So we have single-sided PCB here, which is actually bowed and very flexible. There's absolutely no support down the center of the PCB here to stop vibration damage from occurring. So yeah, single-sided PCB as well, very thin as well. And for the power supply section, we have the good old standard TL494 chip, which is the classic in every amplifier you'll mostly come across. And then we have the TL494 generates pulses, which are buffered by well, this camera is very difficult to navigate. That is then buffered by these drive transistors over here. When it does a focus, there we go. These drive transistors buffer the pulses, and then it goes to the gates of the power supply MOSFETs over here. Here we've got the two power transformers. So we've got a pair of power transformers. These are the 12-volt filter capacitors. These are the rail capacitors, if you could call them that. They're pretty small. And then for the output section, we just literally have 4 channels worth of output, really basic Class AB. But the thing I have noticed though is that the output transistors are the larger package style. I think this is TO247 Max package, so these are pretty big. Now the advantage of having output transistors in this size is that they can dissipate a lot of watts. So when you're looking at MOSFETs or transistors, they'll have multiple different ratings, like total current, like in the amount of current that the component can dissipate. And they also have a power rating. Now, when you're starting out, you might think, oh, well, the power rating is going to be exponentially like proportional to the current rating. Well, that's not always the case. Let's say you've got a transistor or MOSFET, it might be able to handle a high current for a brief moment, like just for a pulse, but it doesn't have the ability to get rid of all of that heat generated by that high current quick enough. So it might have a high current but a low power handling. Additionally, you might have a transistor with a high power handling, which means that it can get rid of a lot of heat, watts of heat, but it doesn't have a particularly high current threshold limit. So that in that case, you have a transistor that can stay on all day long and dissipate all the heat generated by whatever current it's passing. And the flip side of that is you have a transistor or MOSFET that can deal with a huge current burst, a spike or a pulse, but it can't take too many of those in a row because it can't dissipate the heat from them quick enough. Increase mic volume. Okay, so I did turn the mic volume down in case it was clipping. Let me know if that's any better, guys. Cool. All right then. So yeah, I don't have a clue about what the faults are of these things. I've literally just been given a box of amplifiers and told that these ones were returned from Amazon. So I guess the first thing to do would be just to check that any of these have any dead MOSFETs or transistors on the power supply or output section. I doubt they will have. I imagine that these are probably going to be fine. Guys, guess how many of these do you think are probably going to work perfectly fine? You'd be surprised how many people return stuff because they think it's broken, but they're just not quite sure how to use it. So I'm going to start off with the power supply here, power supply MOSFETs. Okay, so power supply MOSFETs don't appear to be shorted on this side or on this side. Outputs, let's check this channel, channel number 1, channel number 2. We're looking for shorts, channel number 3. And channel number 4. Okay, so there's no shorts on the board, so that allows us to go ahead and power the thing up and see if, rather than drive waves, because this is a Class AB, we are looking for a sine wave. Sines and squares and drives. So let's go ahead and plug this power wire in over here. So this one, the fault is either going to be that the signal doesn't get through the amplifier. There might be a broken trace somewhere, or just part of the circuit wasn't assembled properly in factory, preventing audio getting there. It might not turn on at all. It could have an issue with the remote turn on circuit. It could go into protection, could have a protection circuit fault. Okay, there we go. Power going in. It's missing a bunch of grub screws here. I wonder why that is. Okay, let's turn our cheeky power supply on. And we're going to give it 10.8 volts. Why not? So I like that number. And let's go for 4 amps worth of current going into the amplifier. Let's turn it on and see what happens. So I am initially looking for a square wave on the power supply effect drain, which is this one over here. So I would like to see a square wave here when it comes on. Where is my foot pedal? Here it is. Oof! Okay, that is drawing some damn current. I mean, that's a lot of current for just an amplifier coming on idle. 5.7 amps, and it's not actually improving. Okay, so that is drawing a bunch of current. Yeah, there's no reason that it should be drawing that much current. So whenever you have something drawing current, it means that heat is being generated somewhere. So what I'm going to do is actually take my thermal imaging camera. I think this is probably going to be the quickest way to diagnose this excessive current draw problem. And I'm going to look at the board and see what's getting hot. It could be one of the capacitors, because these are pretty cheap capacitors from factory. Let's take a look in here. So we've got 5 amps going in, which is going to be plenty enough to heat something up. You can see here 5.7 amps going into the board right now. I'm just looking through my thermal imager right here, see if we've got anything getting hot. Something is definitely going to be getting hot because current is being passed. Ah, here we go. There's some heat going on over here with this pair of outputs. That's interesting. I'm going to take away the clamps here, the transistor clamps, to prevent the heat dissipating through to the heatsink, so I can see what's getting hot a little bit easier. Yo, H1 Nicholas is correct on this one. This is going to be a short on the amp side. But short, didn't find any shorts on the output transistor, so it could actually be a driver. I've seen this before, just a driver gone bad on the output section. So let's just check one more time for shorts on this. Ah, hang on a minute. No, there is a short here. How did I miss that? I'm pretty sure I went through every single one of these transistors. So we do actually have a short here from pin 1 and 2 of this transistor here, not 3 and 4, and not 1 and 3. So that suggests that it could actually be rail to ground short. Let me check to see whether it's on any of the other transistors. No, perhaps not. So I think maybe it's just one of these transistors on the output section that's bad then. I'm pretty sure I went through all these. Okay, so we have a shorted transistor over here. I think there was maybe just a little bit of corrosion on the leg here, preventing my multimeter probes getting there. But yeah, that is straight up a short on this one here. So just to confirm that, we're going to see, I mean, I know it's a shorted, but I just want to see it get hot, you know. I just want to see it get hot. So we're going to take my thermal imaging camera. Maybe you can see this on this camera right here. Let's point that towards there. Let's point our thermal imager towards there, maybe. Yeah, there we go. Let's see whether it gets nice and hot. Yep, there you go. You can see it heating up. Ooh, starting to glow nicely. It's taking a while to get hot. Actually, look, it's taking quite a while to get hot. 32, 33. Yeah. So that's our issue then. All right, cool. Dead outputs. Now, unfortunately, I actually should have thought about this before I started this live stream. I don't think I actually keep in stock these parts because they are slightly strange parts. They're like the bigger TO247 Max parts, which I don't generally tend to keep in stock. But let's just see. I do have a couple of these. So this is a let's get this camera up here. So the part number, if you're ever struggling to read the part number on any of these, what you can do is just dab a little bit of this thermal paste and wipe it over the part. And you can see there that instantly the marking becomes semi-readable. So yeah, we have a 2SC 5200 and a 2SA 1943. Let's check my little drawers up here and see if I have a spare one of those. I might do. Got a bunch of drawers up here. Let's have a look. Okay, there's some big parts in here. What do we have in here? What was I looking for? 2SC. I actually do have, I might actually have these parts, you know. That would be crazy if I do. What am I looking for? So I've got that one, and I need the 2SA, what was it? 1940, can't you see it? 1943. 2SC. 1943. These are all the NPN parts. $19.43. There we go. Got a spare one. Excelente, excelente. So I might actually be able to fix this for you then. So, although it looks like we might only have one transistor there that's dead, which one was it again? I can't remember. I felt like the short I read on the 2SC, but the heat was actually coming from the 2SA. Oh no, it is, no, what the hell? Yeah, so it is the 2SC that appears to be shorted. I'm curious actually, because sometimes it might not be the output, it could actually be the driver. Because hey look, we've got a 133, look, check this out. We've got a 133 ohm on this one too, so what I'm going to do is I'm going to pull these two outputs, I'm going to pull these two outputs out of the board. Pull these two output transistors out of the board, and we're going to go ahead and test both of these outside the circuit. And yeah, that should be a nice easy fix on this one. Just got to take this bitch apart now. How's everyone doing on the live chat? Let's have a quick look. What have we got going on the output on the live chat? Hey Sam, still waiting on the Triumph Smart 3 video. I did the Triumph Smart 3. Oh, do you mean like where I get one myself? Nah, that ain't happening unless somebody sends one to me. So Derek, Big D Wiz, no, what's his channel called now? Williston Audio or something. Yeah, he buys all of his own amplifiers to do the amp dyno videos with, and then obviously he makes that back in YouTube revenue. I don't think that if I did a video on the Triumph Smart 3, I would get enough views and stuff for me to make the money back on the Triumph Smart 3, so I don't think there's much point me doing that, because I'm not going to obviously spend my own money and waste my own money on an amplifier that I'm not going to use. If someone sends one in to me for repair, then I will gladly do a video on it where I check to see whether my theories on that were correct. But going by all of the stuff that I saw on Derek's bench test and the shape of the wave, etc., that happened on his oscilloscope, I'm pretty confident that most of my information on that video was pretty accurate. But yeah, it's hard to say without actually getting one here to check. So if anyone that's just joined, we are repairing a bunch of amplifiers by the brand Pile. I don't know if you have this all over the world, but this is like your kind of really entry level cheap Walmart, Amazon, like budget level amplifier stuff. So these are all Amazon returns. So I'm just going to repair a bunch of these, see what the common issues are with them. So this one's got dead outputs, which I thought would be slightly less common. I thought that most of these were going to be silly manufacturing issues. But it's possible that, like I said at the start, the user has bought this amplifier in order to run subwoofers with, and that is why we have dead output. Maybe he ran like the subwoofers just on that one channel or something, because it's a 4 channel and he doesn't know how to hook subs up to 4 channels. It's very possible. Anything is possible when it comes to Amazon returns, hey? I'm going to try and look for a nice quick way to get these boards in and out, because one of the longest parts of amplifier repair is actually taking the boards out of the heat sinks and reassembling them, and it's the most boring part. Do you fix PPI PCE 250? Maybe. I can certainly check it out for you. Only if you're based in the UK, however. I don't do repairs from overseas. It's too complicated with shipping costs, and it costs too much to ship, and then if there's any issues with it, you can't ship it back. It's just a nightmare. Do you have any idea how to fix the DXB 3BX series 3 impact restoration? I've no idea what that is, sorry buddy. Not a clue what that is. I have a 5K Belva amp running 2 audio pipe, slapping. If you're running a Belva amplifier, for the love of God, do not mount it to your subwoofer box. The Belva amps are some of the most poorly assembled amplifiers that I've ever seen, and they will die with vibration damage given half a chance. So take them off the box if you are running a Belva amplifier on the box. Yeah, definitely do not run a Belva amplifier on the box. Not going to end well for you, my friend. Got a bunch of screws in the board here, and there's also some screws underneath this preamplifier board, which is a bit of a pain in the ass because now I've got to take this off to get to the screws underneath there. Now usually with a class AB amplifier, well not all, but with like most decent class AB amplifiers, when you replace the output transistors you need to rebias the channel. Now biasing is essentially how much overlap you have between the NPN and PNP transistor turning on and off. So class AB being, you know, A and B, so basically an NPN and a PNP transistor will both generate the sine wave, and there will be a little bit of overlap where they're both turned on at the same time in order for there not to be like a little glitch in the sine wave when the transistors switch over from being A to B, if that makes sense. And so the biasing is how much overlap there is between the two transistors. Now, the higher the bias you have, generally the nicer the amplifier will sound because the less crossover distortion you'll get between A and B. However, they will run hotter and less efficient because they generate heat when they cross over and they're both on at the same time. In these cheap amplifiers you don't have any biasing of any sort, so generally they're not particularly nice sounding. How the hell is this coming out? What is this stuck on? Oh, I see. Great design there, Pile. Make it almost impossible for this to come out because you put the bloody plastic thing in the way. Right, there we go. It's like there's like a plastic riser nut that gets in the way. You can't take it out. Okay, here we go. How's the new power base 30k amps? Did you repair any before? Not really, no. So the UK base scene is much smaller than elsewhere in the world. So those great big power amplifiers we generally don't see a lot of. I'd be interested to repair one. I'd be quite scared to repair one because naturally those things have crazy high internal voltages. Like, so the Tarrant base 30k, that's getting to the point where if I touch the wrong thing, I am dead. So I would need to take extreme care when repairing something like that. I wouldn't really, I wouldn't really choose to repair something like that if I can avoid it, to be honest. One more screw and we are out of here. What's up, Jack the Ripper? How's it going, my man? Good to see you. Okay, cool. Let's flip her over. Just getting rid of my pedals. Ah, that's it. That's the one I wanted. So yeah, I believe that the dead transistor appeared to be over here, which you can't actually see. The camera's in the wrong place. Yeah, this appeared to be the dead transistor location. So let's just confirm that these are the ones that we need to work on. Actually, hey, look at that. I told you it might be manufacturing defect. Wait for the camera to focus. Do you see what I see? Ha ha ha! What is this? This is a solder bridge. That's a solder bridge from factory. Great quality control, eh? You testing every amplifier, making sure it's working perfectly silky smooth before going to the customer. I don't think so, eh? Yep, that's going to be our problem, guys. And that would explain why we only measured continuity between these two pins and like not any of the others. So yeah, that's going to be the problem. I wonder whether it might have actually killed any of the parts in here. What I think probably happened was when the customer got the amplifier, they hooked it up and it would have blown the fuses straight away, okay, because it was drawing excessive current trying to, there's a short there. So it blew a fuse. They probably replaced the fuses. It blew again, and they were like, hey, this amplifier's stanky, it's blowing my fuses all day. So then it got sent back and tested, and they were like, yep, this is blowing fuses. So yeah, that's probably the only problem. I'm going to go ahead and remove that solder bridge. Bye bye. And just because that's kind of a bit overlap there, I'm going to go ahead and reflow that area. So actually now that I've removed that bridge, let's just see. The short has actually gone away. So now I'm reading 512 on diode setting, and the other way around we're reading 600, and no, it's climbing, it's charging a capacitor 800, 900, 1000. So that's possibly going to work. There's a bit of funky soldering going on here. I don't know, see this looks a bit janky. I don't know whether that's just like residue from being assembled, or whether this part has actually got really, really hot as a result of that solder bridge, and has like melted the solder and then reset again. So that part might be something we need to look at, but I'm just going to reflow that area where the solder bridge was and see whether that fixes it, yo. Just get this camera in focus. This camera loves to not be in focus. It's like, hey, do you ever have that, right? When you're just like sitting there daydreaming, and you massively phase out, and you know that you're kind of blanked out, and your eyes defocus, and you're deep in thought, and then you become aware that you're deep in thought and totally phased out, but you're too lazy to like come back. You're too lazy to refocus your eyes. It just feels so relaxing to just sit there with your eyes out of focus and just be like, That's basically what this camera likes doing here. It loves doing that. Ah, I've got the wrong solder tip. I thought I had the... Oh, never mind. This should still work. I just want to sort of cook up this solder a little bit here, just to get rid of that overlapping bit. There we go. That'll do. That's fine. That's a fine. Okay. So I'm just going to turn it over. I'm going to try and power it up again and see if the current draw is gone. Get back in there, y'all. Right, there we go. So my cables are still in. Nothing is touching the heatsink that it shouldn't be. Yep, that's a bit high. Okay. Yep. Looking good. That's all still in. Okay. So yeah, let's power it up and see what happens. A bit of power. I'm going to turn my current draw down to like sort of 2.8 amps. I'm hoping this isn't going to draw excessive current anymore. And let's see what happens. Power supply MOSFET drain. Whoop! Ta-da! Ah, would you look at that? 0.4, 0.7. There you go. So this is obviously the idle working current of this this amplifier. Now let's just check that we have rail voltages present. So let's check the second pin of this one. So what? 27 volt positive rail and a 27 volt negative rail. Sweet, so that's looking good. The only thing to do next is to reassemble it and make sure that it actually makes audio on all of the 4 channels. One very important thing, which I only really discovered recently, because like I say, I'm not really so good at Class AB amplifiers. If you're working on a Class AB amplifier, especially one that uses MOSFETs in the output section, and also especially ones that have bias potentiometers, okay? Maybe not so much these crappy things that aren't really biased, but yeah, any decent Class AB amplifier that has bias pots, or especially MOSFETs on the output section, when you're working on them, do not leave the amplifier powered up on idle with the circuit out of the heatsink without it all clamped down. Okay, it's very important. So basically, the way that some of the Class AB amplifiers work in the biasing, I never went to engineering school, I never went to electronics school, so I apologise if my terminology is wrong here. But the outputs, like I say, we have transistor A, transistor B, and there's an overlap between them. Okay, and that level of biasing, that level of overlap, changes with temperature. Okay, as the transistors get warm up, or as the temperatures change within the circuit, it will affect the level of bias. and there is a transistor that is always clamped on the heatsink right next to the outputs that detects this change in temperature and adjusts the bias accordingly. Okay, so if you run the amplifier out of the heatsink, then that transistor that is detecting the heat and adjusting the bias accordingly can't do so it doesn't know how hot the outputs are getting. And so what happens is the outputs will go into thermal runaway because they heat up because they're overlapping slightly. So naturally they will heat up as you got the amplifier on idle, and they get hotter. And as they get hotter, the bias changes and it draws more current. And then they get hotter because they're drawing more current, and so the bias changes and they draw more current. So there's an absolute cascading runaway domino effect of heat. And unless you are aware of it, unless you've got a thermal imaging camera, or you smell it, or you catch it in time, you will kill the outputs just by running it on idle like that, because they just reach their thermal limit and they just go up in smoke. As this actually happened to somebody that was asking me about amplifier repair, and I was helping them repair their amplifier by email. And we didn't get to the point yet where I said, yeah, go ahead and power it up, but they powered it up and they left it on idle for a few minutes, and another channel that was fine earlier then went up in smoke. And then I explained why, and now he's replaced all the outputs and biased it correctly, and it works fine. But yeah, if you're doing Class AB amplifiers like that, they need to be in the heatsink before you run it on idle for any considerable length of time. Okay, yeah, what am I doing now? Reassembly and checking for audio. This needs to get back in here properly. Oh, this is built like a pile of poo. Okay, there we go. Let's get some screws in, stop it moving around. Let's have a look at some live chat. Hi, how are you? I'm very good, thank you. Too much flux. Actually, hey, that's one thing that I don't really use a lot of. So flux is amazing stuff when you're working with electronics, repairing electronics and circuit boards and stuff, but it's more useful when you're working with very small electronics and IC chips and stuff like you'd find in MacBooks and motherboards and stuff like that. So solder, the solder that I use and the solder that most of you should use is flux core. So it actually has flux in the center of the solder wire, and so as you solder with it, it releases flux onto the thing that you're soldering, and I find that is, for these large components, more than enough to work with and to get a really, really good solder connection with. The time when it doesn't work is when you're resoldering IC chips and stuff with a hot air station. So yeah, like removing old chips and soldering new chips on where they need to be in exactly the right position, where the legs and the pads and stuff are so close to each other. Flux is like absolutely so useful. So I use flux in my soldering wire for most jobs in amplifiers, but when I do small stuff, yeah, it's really useful stuff. I know Lewis Rossman loves it, and he uses an absolute butt ton of flux all day long. And that's cool. Can you fix a Sir Vega V600.4? Maybe, I don't know. Until I look at it, until I try and diagnose the problem, I've no idea. But probably. I bet that Sir Vega is one of those like Class D 4 channels. Like I have no idea. I don't know what that amplifier looks like because we don't really get much Sir Vega stuff over here. But I imagine that's probably like those kind of Crescendo or the JL Audio. Well, what the brand is it? Yeah, Crescendo Symphony. Those little Class D 4 channel things. I bet it's like one of those, and those use, I think it's 2092 drivers in the output section. With output MOSFETs that are like 4227s maybe, and they're very fragile. They run at a very high Class D switch frequency as well. They tend to like to kill diodes, those amplifiers, so if you're having problems with those amplifiers, look for the feedback bootstrap diodes and stuff like that. Oh man, this is a pain in the arse getting this in. Come on. There we go. I keep waiting for more demo vids from your van. Yeah, so the van, okay, here's a little story with the van. Oh, nothing bad, don't worry. I just wanted to make some changes to the enclosure. Right, so when the van was built, some of you may or may not know, the van wasn't built with the intention of putting the Z4s in there. The van actually started off as one of my customers' vans. So basically a guy came to me and he said, Sam, I want you to supply me with a whole bunch of sweet DD audio, and I want to get a build done in this van that I have. So it was an empty van. And I said, yeah man, absolutely, I can supply you with lots of stuff, and I can give you the details for my acoustician, Mr. Henry at Harvard Acoustics, to do the build for you. So that's what happened. So this van was actually built originally for the equivalent of like DD, it was basically 700 series. So these are like the kind of more budget, and the more budget level 1500 watt RMS 15s. Okay, so like a pair of those, and then it had obviously the front end as it is. But the bass enclosure, the subwoofer enclosure, was built for lower power subs to start with, right? And as some of you will know, if you really know about your audio and stuff, as you increase motor force and as you increase power, you need to decrease the box volume or make the port larger if you're burping. But generally you decrease the box volume. So otherwise what happens is you reach mechanical excursion limit before you reach the power limit or the thermal limit of your voice coils and stuff. So obviously where this van was built with intention to use with 1500 watt subs, now I've now got flipping DDZ4s in there. My issue with the build is that I reach a certain level of output, even at box tuning, and my subs are just moving far too much. They're already at excursion limit. So what I need to do is probably make the low side in the 6th order smaller, and make some changes to the port to get a bit more port load going. You know, to load the woofers a bit more. Get some more get some more port load, and that will increase my output as well. So yeah, I actually removed the subs from the van in order to take them to Mr. Harwood Acoustics to make some box changes. And if you've watched the video of me putting the subs in the van, you know how much of a flipping headache that was to get the subs in. You have to take the motors off. That is one of the only builds I've ever seen where you have to take the motors off the subs to mount them into the box, and then put the motors back on the subs whilst the baskets are mounted on the box. Yeah, go figure. That was all planned to happen the week that we went into lockdown from the coronavirus. So naturally that's now not happening. So yeah, I did plan to get a whole bunch of new videos with the van, but that's going to now be on hold until I make the changes to the enclosure. But it will happen. Updates with the Proton. The front stage is pretty much finished. I have my T-line doors in the car. They're sounding and looking beautiful. I will do an update video on those shortly. And I still have some work to do in the Proton. Still got a DSP to put in. Crap. I still got a DSP to put in. I've still got the subwoofer install to finish up in the back as well. So yeah, bit of a long way to go still with the Proton, but the front end is all in and finished and sounding amazing, even without a DSP. Okay, because of the positioning. So DSPs correct time alignment issues, EQ issues, crossovers, like perfect crossovers and stuff like that. But because of the positioning of the speakers that we've done in the Proton, minimal time alignment is required, to the point where I can get a very almost perfect stereo image, like and centered and very sharp focused image on the dash just with the time alignment in my old school Alpine 9855R, which actually has pretty good time alignment features on there. And the crossovers, yeah, I don't really, the crossovers, that head unit has all the crossover features that I really need. So I pretty much got it to like 90% just with the head unit, just with the features on that. But DSP will definitely improve things even further, and then getting the sub install done and everything will, just bring it to life even further. So I'm looking forward to doing that. Why are toroidal transformers better in hi-fi amps? Toroidal transformers are generally better across the board, I believe. I'm not a transformer expert, so I'm not like massively clued up on the complete ins and outs of transformers and what makes them efficient and stuff, but I am led to believe that toroidal transformers, tell me if I'm saying it wrong, those types of round donut transformers are better in general. They're more efficient, and I think it's due to the shape and stuff. They don't, you can basically pass more current through them, they're a bit more efficient, and they don't run as hot. But if anyone's an expert on transformers, maybe H1 Nicholas can tell you guys more about why these types of transformers are used and why sometimes they're not relevant. But yeah, I believe that they're just better across the board. If you look inside any really high-end PA amplifier, like Crown Amplifier, Crest Audio, etc., you'll find those toroidal transformers used. What is the RMS on that Pi lamp? That's a really good question. That's a really good question, because the RMS, I guarantee you, will be massively inflated. So I would bench test it for you, but that's going to take a bit of a while, because I've dismantled my my high current power supply setup in order to kind of tidy it up a bit and clean it up and make the wires a bit nicer and stuff. So at the moment, I haven't just got an easy, quick plug and play high current power supply to put in. However, saying that, I bet that I wonder whether this amplifier is so weak that I might actually be able to kind of bench test it on my 20 amp bench power supply, like per channel. Obviously I won't be able to test all channels at once, but I wonder if we can get a single channel power rating, which will obviously be higher than if all channels were driven, but I wonder if we can get that just off of 20 amps. What fuse rating has this got? This has got 2 fuses. It doesn't actually say what rating they are. There's one fuse in the side of this amplifier that's an orange one, but I don't think that that's original, so maybe I'll have to have a look on the internet and see what look at a picture and see what fuses it uses. Actually guys, if any of you have internet browser open just now, just while I'm screwing this up, see if you can find what fuse rating this amplifier takes. This is the Pile Power, what is it, PLA 4478. So Google for me, PLA 4478, let me know what the fuse rating is on that if you can, and then we'll see whether that's going to be possible to maybe bench test on my little bench power supply. How's it going? All the way from India. Pradeep, how's it going? Good to see you, man. Thanks for joining us. What's your favourite DSP? I get on best with the Helix. I really like the Helix DSPs. I just find them easy to use. They're very intuitive and they're very, like, they update quickly. I can't stand slow, laggy user interface. So yeah, the Helix they just do what they say they're meant to do. Here we go. Some information on transformers in the chat. EIA core transformers are better in situations that pass signal. Toroidals are hard to design for high fidelity units. But in terms of power transformers, toroidals are way better in terms of power to weight. Interesting. So that I didn't actually consider that. I didn't consider that maybe sometimes you would want to pass a signal through a transformer and not have it, modified in any way, or have it retain its quality or shape and whatever. So that makes sense. Lack of noise and stuff like that. So I wonder how many of these amplifiers that have come in are going to be something as simple as a solder bridge from factory, hey? That would be really interesting. Okay, I think that is all of these screws put in. I've just got a couple more here. I've got to put this big end plate back on. Maybe what I'll do for the next few amplifiers is any that I fix and find the fault on and fix them, I'll just put them to one side to reassemble later on off camera, because it takes up quite a lot of stream time reassembling the amplifier, and that's kind of boring to watch. My SPL Dynamics D8S just broke on 20% power protected, and with next turn on from the head unit it just smoked. Ah, shit. So I'll tell you what happened there, Co-Vinch. Sadly, these old Korean boards, the protection circuits were not very clever. Okay, so what happened to your amplifier is it was on low power, which is fine. Most amplifiers don't blow under high load. So unfortunately, an output transistor, an output MOSFET or a driver or something in your output section of that amplifier just decided to give up. In the same way that a light bulb can just blow randomly, yeah? So your amplifier just killed something in the output section and it will have blown an output MOSFET, okay? That will have triggered the amplifier to go into protection mode because it detected there was DC on the speaker outputs and it went into protection mode to save the amplifier. Now, the problem came when you switched it off and then went to switch it back on again. On these old Korean amplifiers, when you initially turn them on, the protection circuit is disabled so that the high current inrush of charging the rail capacitors doesn't trip the protection. Okay, so for the first like brief moment of power up on those amplifiers, there is no overcurrent protection. So obviously with a shorted output MOSFET in the board, you then flick the power back on. The power supply MOSFETs and the power supply section will have then been trying to drive a direct short on the output section. I won't have been able to. The current will have saturated the transformer, which then would have presented a short circuit to the power supply MOSFETs, which then would have exploded. So that's why it smoked. So unfortunately, the power supply section was fine until you switched it back on again for the second time and then killed the power supply section. That's one thing that I'll always do from now on. If you know, with any of my systems or with any of my amplifiers, if any of my bass amplifiers, if any of my amplifiers go into protection, okay, I will take the amplifier. Like if I notice it's in protection, I'll be like, shit, it's in protection. Like it's gone into protection for a reason, okay. So I will then take the amplifier off, away from the car. I'll bring it over to the bench power supply and I'll power it up on low current to see what happens. For that exact reason, because trying to power up an amplifier that's gone into protect due to a dead MOSFET will cause it more damage than it originally had before. Guaranteed. Okay, cool, that's all now back in the board. So I'm going to power it up again, and this time I'm going to apply some signal, and we're going to see whether each channel has a sine wave on the output. So I imagine it probably does, because this is a brand new amplifier, and the only issue was the solder bridge. I can't see why it wouldn't have sine wave on outputs, unless that solder bridge killed a driver perhaps, but it wasn't drawing any excessive current. Let's just check all the settings on the side of this amplifier. I'm going to go full range on both of these. Bass EQ, low pass, high pass level. I'm going to go 2-channel mode so that I don't have to plug multiple RCAs in. Let's turn the scope onto a lower frequency reading mode. Okay, power. Alrighty then. So we're looking for a sine wave on the output, so I might need to increase the amplitude slightly for this. Okay, there we go. So we've got a sine wave, and that is on channel 2. Channel 2 has a sine wave. Looks pretty nice. Clips off quite low actually. And then we should also have a sine wave on this one. Yay! So that's channel 2 and 4. Let's now try channel 1 and 3. Channel 1 and channel 3. Excelente! So, small issue with this amplifier was the fact that it had a solder bridge. Now, in order to bench test this amplifier to see how much power it does, like I said, it's going to be a bit of a headache, not possible. Actually, did anybody find out what the current draw of this amplifier was? 40 amps, here we go. 2 times 40 amp fuses. I think, yeah, that's going to be far more then. So 40 amps, that's 80 amps, divided by 4 is 20 amps. So it's on the limit. Per channel, it's on the limit of my bench power supply. So in order to see roughly how much power this is going to make, okay, instead of plugging this into a high current power supply and instead of running this on a load, what I'm actually going to do is I'm going to run it without a load, but what I'm going to do is actually, rather than give it 14.4 volts, I'm going to give it 12 volts. Okay, now getting a reading of the sine wave amplitude at clip point unloaded at 12 volts is it usually works out to be about what the 14.4 volt loaded power rating is. So I've done some calculations on this before and I've done some comparisons, and it usually works out plus or minus a few percent worth of tolerance or whatever. So let's try that then. Let's put this back into channel number 1. Okay, let's turn this to 12 volts exactly. There we go. Let's power her up, and I've got a 50 hertz sine wave on the signal generator here. And let's see the RMS voltage of this sine wave at clip point. So it starts to clip off about there. So that's doing about 20.7 volts RMS. There you go, you can see that 20.7 volts RMS at clip point. If we go any higher, you see there it starts to clip off. So about 20.6, 20.7 volts RMS. So each channel, I assume, will be 2 ohm stable. I haven't got the browser up, so can somebody just confirm that this is 2 ohm stable per channel? I believe it is. Now let's just bring up the little calculator here. Let's work out how much power that would be. So we have 20.7, and also you have to remember that no channels are loaded here, so this is probably going to be a slightly exaggerated power figure, but it will be somewhere there or thereabouts. And the resistance, we're going to do 2 ohms. That's going to be about, well, apparently it's going to make around about, is that correct? 200 watts per channel. What we can also do is we can also use the fuse rating to go by. So this is 2 times 40 amp fuses, okay? So that's 80 amps worth of current, total current, whatever. And that is at 14.4 volts, I imagine. So times 80 times 14.4 gives us 1,152 watts. And then efficiency-wise, this is a Class AB, so it's probably going to be somewhere around about like 60% efficient at best. Like, let's just pretend it's going to be around about 60% efficient. So we're going to then times that by 0.6, best case scenario. We've got 691 watts, and divide that by 4 channels. Divide that by 4. That gives us 172 watts per channel. So okay, yeah, going by my rough calculation based on the amplitude of the sine wave and the amount of current that this amplifier can draw without the fuses blowing, we're going to get somewhere between 170 to 200 watts RMS per channel, which actually, it's not too bad. That's actually a fairly decent amount of power. Okay, this isn't going to be a particularly high quality amplifier. It's not going to sound very nice on high quality component speakers, but if you're running a big, like say you've got like a bunch of PA speakers in your doors, you know, that's going to be a decent amount of power to them, and they're going to get loud and you'll be able to hear it across the car park. And you know, I imagine these things are pretty cheap on Amazon, so yeah, that's actually doing a bit more power than I thought. It's nowhere near the quoted 4,000 watts, of course, a bunch of bullshit they put on these amplifiers, but anything over, you know, over 150 watts per channel is not too bad. Alright, cool, that's number 1 down. Let's move on to number 2. Shove this back in here. I think we screwed everything back down. Check, yep, check. That one's done, that one's in. Yep, these are all in, that's all in, that's all in. Cool. So if anyone's just joined us, the fault with the first amplifier was a solder bridge from factory. You'd be surprised, that's not the only time that I have seen that. I actually went to a car show in the summer of 2018, I believe it was. And I took all of my amplifier repair stuff in the back of my van, and I was doing amplifier repairs at the show. So yeah, people were like competing in their bass comps, blowing amps and stuff, and I was you know, doing some amplifier repair on the day there, if anyone needed it, of course. And one guy was running a whole bunch of B2 Audio MA 6000.1, those full bridge amplifiers from B2 Audio, and he was running like 6 of these amplifiers. I think it was a massive build, and one of the amplifiers was just constantly in protect. Like, you power it up and it would just go straight into protection mode. And I actually found that this amplifier had it had a solder bridge from the positive speaker terminal to ground. Yeah, get that, right? From factory. So I removed that, and then it played all day long. That's not bashing any brands, by the way. I'm just proving that it doesn't matter what brand it is. During assembly and stuff, mistakes can happen. Solder can like get spewed onto different traces, and yeah, it can happen. Más videos en español. My Espanol is not that great. I did do a repair video in Spanish, as you may or may not have seen. Actually, where the... This always happens. I'm left with 2 screws spare. Why have I got 2 screws spare? I don't think I couldn't see any screws that were missing from inside. It's that joke, isn't it? It's like you put something back together and you're like left with like a couple of parts left over. Why have I got 2 screws left over? They're like long boys. Whatever. $1 hour for 1 amp. Yeah, but you have to remember that I'm doing a live stream, so I'm talking and getting involved with you guys at the same time. If I was doing this not in a live stream, then this would have been obviously much quicker. But also remember how long it takes to disassemble and reassemble the amplifier. That, like I said, that is the thing that takes the longest amount of time when you're repairing amplifiers, is assembly and disassembly. Like, the fault was easy, just remove the solder bridge. So if you've got to take the board out, it doesn't matter how easy the fault is. Cool. I'll go and get number 2. Okay, so again, another pile amplifier, and this looks like it is the smaller version. So this is the 4-channel 2000 watt. So it's the same kind of thing, but it's just a smaller version of that. Let's get this bad boy out of here. There we go. Let's have a look at some live chat real quick. What do you think about Banda amp? Still have that problem, faulty FETs? No, they fixed that now. Banda are now some of the best amplifiers coming out of Brazil, and it's what I will recommend to most people if they're looking for high power, high efficiency, low cost. Banda boards are out of the Brazilian stuff, some of the best that I've seen in terms of design and reliability. Yeah, I did screw in the little board. I screwed in the little board with the nylon standoffs, so I'm not sure where these other ones came from. Very strange. Let's see what else we've got going on in here. Yeah, I've heard of this tri-wiring type of thing on a 4-channel amplifier. It can be done. Yes, the reason that I don't use the cordless tools on most amplifiers is because I would then just be tempted to use them on the MOSFET clamp screws, which from experience is a very bad idea, because you're screwing into aluminium, which is generally very cheap aluminium, and it's not been designed very well with the threading and stuff. So literally I need to be able to feel the amount of torque that I'm screwing up the clamps with. I need to make sure it's tight enough, but not to the point where I'm breaking the thread and it's just going to spin, because it's very important that those clamps are really tight against those FETs pushing on the heatsink. If the thread breaks, or if you round it, or if you mess it up and it just spins in the hole, then that is game over. You've got to then re-tap out a bigger screw, and maybe the bigger screw doesn't fit because the FETs are too close. It's a nightmare. So I would always use hand tools. Always recommend you use hand tools when you're doing that, especially with the clamps. And then I've just got used to just doing it with my hands with the heatsink. It's the same issue. Use a power tool, and it's very, very easy just to go too far and it ends up spinning just in the hole. Like these things, you put the tiniest bit too much pressure and that's it. So I generally would much rather use hand tools. Apart from obviously unscrewing. Unscrewing is fine with power tools, but I also hate recharging the batteries of those things. Like, they literally don't last long at all. Like, the amount of amps I take apart and put back together, most of the time the thing will just end up on charge, and you know, I'll just like whatever. I'll just keep my wrists nice and strong. I don't get a lot of exercise because I'm just in the workshop all day long, sitting down on my arse. So if I can, you know, keep my arms and wrists and all that exercised, I know that it's probably going to be a repetitive strain injury because of the motions that I'm doing, but I try and change it up every now and then. So let's have a look at this one then. So we've got the same kind of thing going on as the bigger one. However, we have normal sized TO 247 AC sized components rather than the max parts that were bigger in the other one. Single transformer this time, just a pair of rail caps instead of 4. But similar looking drive circuit, although slightly smaller. The other drive circuit had bigger final drivers. So okay, let's see what we got going on in this one then. As before, the first thing we're going to do is check for shorts across the power supply transistors, power supply MOSFETs and output transistors. Ooh, oh dear. Well, that's interesting. Oh no, is that a diode? Hang on a minute. Oops. So this one, I measured that and it's a short, but it's actually a diode. That's actually the rectifier, so that's fine. So we don't have any shorts on the power supply FETs. That's the rectifier. That's the FET. So we've got 3 FETs each side. So these 3 over this side will be like push, and these side will be pull, push, pull the transformer to get some. There we go. This one's fine. Okay, so power supply FETs are fine. Let's go through each of the output transistors and see if we have any shorts on these like we did last time. Nope, it's good so far. I'm pushing nice and hard. I'm scratching away at the leg a little bit here. Okay, so this one doesn't appear to have any shorts between any of the legs of the output transistors. Just a quick check for visual damage. Can't see anything burned or any visual signs of failure or water ingress. Again, terrible build quality, very, very flexible PCB, single-sided PCB, pretty nasty build quality, but it's cheap, so what do you expect? Next thing to do then is put some power into it and see what happens. So this one actually still has both of the original fuses fitted, 25 amps, which means that this one is unlikely to be drawing excessive current. If it was drawing excessive current, just like the last one we saw, it probably wouldn't have any fuses in it because they would have been blown and taken out or replaced, etc. So I imagine this one's probably going to come on fine, and if it does have an issue, then the issue will probably be that the audio is not passing through it. Third Era, thank you very much for the 199, my brother. I appreciate the kindness there. What's going on, my man? Matthew, so we're looking at Class AB, cheap and nasty Class ABs from Amazon, Pile Power PLA amplifiers. These are all Amazon returns, so these are ones that were bought and then returned because they didn't work. Either that or the customer didn't wire them up properly. So the first amplifier that we saw was very simple, it just had a solder bridge, which is a manufacturing defect on that one. Okay, let's give this thing some power, see what the jam is. Okay, so instantly there, it comes on instantly with a 0.5 amp idle current draw. So let's just go ahead and check the power supply FETs for a nice wave on here. Yep, looks good to me. Let's check that we have rail voltages present. Plus 25 on the positive rail and minus 24.8, yep, there or thereabouts on the negative rail. Okay, looking good. Make sure that we don't have any DC on the speaker terminals. We shouldn't do, because if we did, the amp should be in protect, but you'd be surprised. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's no DC on any of the speaker terminals. Looking good so far. Next thing to do then is to plug some signal into the amplifier and see if we get audio on the outputs. I'm going to throw it into two channel mode so that I don't have to plug in multiple RCAs, and then I'll switch it into 4-channel mode afterwards if that does work. So channel 1 and 3 first. Okay, sweet. that works. So we have audio output on channel 1 and on channel 3. Let's do 2 and 4. Channel 2. Wait, 1, 2. Channel 2 and channel 4. Yeah, seems fine. Obviously the last thing to do is to plug a speaker in and make sure that it actually makes audio, actually plays a speaker, you know. I'm also going to increase the voltage to 14 volts because sometimes you can have an issue where the amplifier works on low voltage but not on a high voltage. So 14.6, yep, that's still working fine. We've got 0.7 amps worth of current draw. New clip point is high. Yeah, it seems fine. But let's just get a speaker just so you can see that it is actually working. I'm going to grab one beautiful speaker, lovely little speaker that I bought recently. How many of you guys remember Elemental Designs? Hey, look at this beauty. This is the 9kV.2. My first ever real proper subwoofer was the Elemental Designs 7kV.2. If you've been a subscriber for many, many years, you will remember this subwoofer well from my old videos. And I saw this pop up on eBay and I was like, oh man, bit of nostalgia there, like Elemental Designs have gone out of business now. And this was brand new in box, unused, and I got it for like £20. So I was absolutely chuffed, and it is beautiful. It's immaculate, like I say, brand new. Never been played, never been installed. So very, very nice little 8-inch woofer indeed. So we're just going to use that and just use this to see whether this amplifier works. And I'm confident enough that the amplifier works fine that I'm willing to hook this up to it, because obviously I wouldn't hook up this speaker to an amp if I thought it was going to cause any problems. Let's just grab some spare speaker cable. I don't know how well the woofer excursion will actually come out on the video here. I'm going to wire the coils in series so that I get a nice high impedance to the amplifier. And actually this is the first time that I'll be hooking this subwoofer up. I haven't actually played it yet, I just assume that it works because it's, you know, brand new and it's minty. I have checked the impedance on the coils, so I know that the coils are good, but I've not actually played it yet, so this is the first play. Who actually here owned some Elemental Design subs? Did anyone own the 13AV.2? That was a beast. I'm pretty sure that had used XBL2 technology, I think, if I remember rightly. Okay, so that's all hooked up in the sub. Let's hook this up into the amplifier. Let's turn her over. I'm going to bridge channels 1 and 2 here, I think. No, what am I going to do? I can't run this bridged because of how I've got the RCA, so I'm only just going to run it on one channel for now, which is fine. It's free air and it's a tiny sub. It needs probably about 10 watts to get to maximum excursion free air. It's such a soft suspension woofer, this, so okay, let's get the camera on the woofer. I don't know how well this will look because of the frame rate is very poor on these webcams. But yeah, let's give it a go, hey? See what it does. Helps if I plug the RCA into the correct hole. There we go. Let's play something low frequency, like 27 Hertz. There we go. Lovely jubbly. It's not the cleanest sounding woofer free air. I've heard cleaner. Or it could just be the gasket. Yeah, I think it's just the gasket actually, like vibrating on the metal. Oh, that's better. It's better on that camera, hey? That looks much better. Nice. Let's go even more. Let's just push it a little bit further. Yeah, so I mean that amplifier is definitely working then, hey? Sweet. It was good to see that little baby move. Let's put that back safely. Okay, so that one can go back in the box as no fault found. Like I guessed, I imagine that a lot of these would probably be no fault found, just because of the nature of the type of customer that would buy this thing. It sounds like a lawnmower. Yeah. I actually also have one of the Elemental Designs EU700s, which is the earlier version of their 6.5. They had they brought out the 7kV.2, which was the one that I had when I was much younger. I actually preferred the earlier version, the EU700. It didn't have the same problems with the tinsel leads snapping, which was a common problem on Elemental Design subs, and I just generally preferred the look of it. So I've actually got one of those, and I have played that one, and that one is dead silent excursion. I love the woofers that just move free air without making a single noise. It's beautiful. It's a lovely sub. So maybe if I get another amp like this that I need to test on a speaker, I'll get my old EU700 out and we can check that out. Hey, I also have, actually no, I've got a better idea. I have a beast of a 6.5 inch sub. I have a Digital Designs 1506, which is the ESP 6 inch, which is an absolute monster. If you haven't already seen the Digital Designs 1506, then go and check out some videos and some pictures of that. If I get another amplifier like this, where it seems to work fine, I'm going to dig out my my 1506 and show you some excursion of that beast, because that is freaking awesome. And I haven't actually ran it yet, so I'll be breaking it in as well whilst doing this. That would be pretty cool. So far, this is amplifier number 2. We've had very simple issues, but I realised, and this is why I haven't been doing some live streams for a little while, okay? Because I've come to realise that if I live stream, then it takes me like 2 or 3 times as long to repair stuff as it would do if I wasn't live streaming. Because I'm obviously talking to you guys about it, I'm checking the live chat, and I'm sort of going over things in a slower detail than I would do otherwise. So 2 amps down. Do some more. And by the way, if this gets boring, if they all seem to have no fault or whatever, I have got some other interesting stuff that we could move on to instead. I could do now this is a bit different because this is not an amplifier. I've got 2 things that I'm going to be repairing soon on amplifiers. First thing is going to be a computer motherboard processor socket change. So I'm going to be changing the socket that has bent pins on a motherboard for a new one. I have no idea how well that's going to go. As you well know, the processor sockets have 1,000 tiny little solder balls and pads to line up with. So I'll be using a heat gun for that. That's going to be interesting to do. And another thing is, because Nintendo Switches are so popular at the moment and are so hard to buy and they're in such high demand, I thought about buying dead Nintendo Switches and learning how to fix them. There are some videos on YouTube that have millions of views that show the repair process for most Nintendo Switch issues. So I've bought some broken Nintendo Switches to try and repair, and they will be, surface mount soldering, BGA repair jobs. So that could be really interesting videos as well. So maybe I could move on to something like that if these pile amps get boring. But let's go and get amp number 3. So here we have another one of these 4,000 watt 4-channel versions, the first one that we started with. Let's try and speed this up a bit. Let's crack it open and see what we've got going on inside. David says, how can I get you to fix one of my amps? Well, I'm in the UK, so provided you are in the UK, I can help you out. If you're not in the UK, then unfortunately I can't help you, because there's no point fixing amps from overseas because the shipping costs will outweigh the value of the amplifier. Okay, cool. Let's have a look what we got going on in this one then. What do you reckon? Make a guess, make a guess, make a bet. Is this one going to be... hang on a minute. Look, check this out. We've got one fuse missing from the amplifier already. So that suggests that maybe there was some excessive current draw with this one as well. So, what do we think then? No fault found? Or perhaps this one's going to be the same as before, solder bridge, or a dead part. So let's take our multimeter and have a look. So power supply MOSFETs, they're fine. That one's just charging capacitor backwards. So no dead power supply FETs. Let's move on to the output transistors. Uh-oh. Wait a minute, that's the same as the other one, hey? That has a short between these two here. Let's get this camera up in here. That has a short between these two legs, but these two are fine. These two are fine. These two are fine. So that's gonna probably be another solder bridge. So guys, let me know, do you really want to see me sit and take apart this amplifier again, another one of these amplifiers, unscrew everything, get rid of the solder bridge and reassemble it? But you don't want to see that. Or shall I move on to the next one and see if it's got any more interesting faults? What do you want to see? I mean, I could probably take it apart like relatively quick. I know where everything is. So I could take it apart and show you the solder bridge and then just put it to one side and reassemble it like later. Same position. Next one. Well, what are we saying, people? Shall I take it apart and show you the solder bridge, or do you want me to just move on to the next one? Move on to next. Might as well do it, bro. Okay. Darren's down to see the motherboard. I'm dreading doing the motherboard because I am pretty sure I'm going to make a freaking mess of it. Next, yeah, next. Okay, people are wanting to see the next one. Alright, cool, so let's put this to one side then, because it's going to be a solder bridge as was the last one. And let's move on to the next one, because once I run out of these, I think I've got maybe 3 or 4 more of these to do. Then once I've done these, I can move on to something more interesting like the motherboard repair or the switch repair. The switch repair could be really interesting, so... Right, this is another one of the 4 channels, same again. Let's crack her open and see what this one's saying. Make a bet, solder bridge. So what we got solder bridge, works fine, or dead component. That's our 3 choices. I am gonna bet, so we haven't had I reckon this one's maybe gonna work fine. I'm gonna go, wait, let's check the fuses first. Oh, this is a good sign actually. This is a good little sign. So if one of the fuses is missing, that seems to be the ones that have excessive current draw. So looking at the fuse situation in this one, I am willing to bet that this one maybe has a solder bridge, the same as the others. Are you reselling these? No. So these are Amazon returns that have come in to me from direct from company. So a company has sent me like a massive box full of these and also other amplifiers. And then I'm fixing them and sending them back to the company, who will then probably resell them. There we go. Okay, I'm not even going to bother checking the power supply FETs this time. All I'm going to do is I'm just going to check across the power terminals, make sure there's no short there, because if there's no short here, then there's going to be no short in power supply FETs. No short there, that's fine. So let's go on the output transistors then. Check for shorts across these, just like we did before. 3, 4, 1, 2, 3, 4. Okay, so there's no shorts between any of those output transistor legs. Doesn't mean that we don't have a solder bridge. There could be a solder bridge under the drivers perhaps, and it could be that the fuse was stolen from this one to go into one of the other ones to test. So now let's power it up and see. I'm wondering whether this is maybe a works fine amplifier. Thank you very much, Caraman, for the 5 for lucky finding solder bridges. Thank you very much for the massively kind donation there, my man. Appreciate it, buddy. Okay, so yep, power cables are in, switch are on. Okay, there's no current draw, no excessive current draw. We've got 0.7 amps at idle there. Let's check we have rail voltages. Plus 29 and negative 29.4, yeah, that's correct. Check the power supply wave. Yep, that looks good. Cool, so all that's left to do next is to check with our signal going in that we have audio output. So let's turn this thing onto 2-channel mode to start with, just so I can do this quicker. Full crossover at full, level down at minimum. Damn, the game was turned up pretty much to full on this thing. High pass, low pass, down. Not that it matters because I'm on flat. So channel 1, let's check channel 1 and 3 first. Let's crank that back up to about 50 Hertz where we had it before. Okay, sweet. Yep, there we go. There's our sine wave on channel number 1. And channel number... Oh, hey! That's not good. So there is an issue with this one. I don't know about you, but that's not a sine wave, is it? So channel 3 has a problem. And that will be a drive issue. It's not generating the bottom half of the sine wave, and the top half doesn't come into being until very late. So look, if we check the channel that works, that's the amplitude of the sine wave that we have. If we jump over to number 3, we just have that on it. So that is a different issue. Let's check channels 2 and 4 to see whether they're the same or whether it's just one channel that's bad. So channel 2 has a nice sine wave on it, and channel 4 has a nice sine wave on it. So our issue is only on channel 3. So before I pull the board out, I'm just going to see whether I can tell where the sine wave disappears. Now, remember back at the start of the stream, I said that I hate working on Class ABs. This is the kind of shit that I hate seeing on a Class AB, because where with a Class D I would be like following the drive waves through the drive circuit and to the buffers and stuff. On this one, that wave, that kind of little bump without a sine wave, could be anywhere on this drive circuit. Fortunately, these amps are simple enough that there's really not much to the drive circuit. I could just go ahead and blindly replace all of these transistors and it would probably work fine. However, I'm willing to bet that this is going to be a similar issue to our solder bridge problem, where maybe there's a solder bridge between drivers that's just grounding part of the signal, therefore preventing it from going to the outputs. So I'm just going to confirm to myself which channel is channel 3 that has the problem. I'm going to do that by plugging it back into the other RCA and just going across each of these and seeing which one has the stanky looking wave on it. So it's not this one, this is the good one over here, so it's going to be one of these ones over here. There we go, this channel right here. This is our problema. Now what I'm going to do, just in case it's any poor soldering, I'm just going to hold my probe here on the output and I'm going to give a wiggle. I'm going to wiggle the transistors just to see if any of them haven't been soldered properly and see if the wave changes when I wiggle any of these transistors here. Nope, seems to be staying exactly the same. Okay, cool, so I guess the next thing to do then is to pull this out the board and you're going to see why it's doing that. Let's have a look at some live chat real quick. Check the rail on the NPN transistor of channel 3. Oh, that's a good idea. Could be missing rail voltage. I don't think I checked the rail voltage on all of these transistors, did I? I have seen that in the past actually. Let's just check we have rail voltage on each of these. Negative rail voltage, positive rail voltage. So the rail voltages are present, so it's going to be a drive circuit issue. Start pulling this apart then. Damn, it's 4:21. That's crazy late, man. Thank you very much for staying up so late to watch the nonsense going on here. So appreciate it, buddy. Thank you very much. Ah, Ernesto has a 5,000 watt RMS Viking. Wait, where's that gone? Is it possible to lower the power to about 3.5 RMS through the gain? Yeah, of course. Obviously, the more that you turn the amplifier up, the more it's going to be doing its rate power. So an amplifier isn't obviously going to be doing its 5k at all times. It's only going to be doing its 5k when the sine wave amplitude gets to the clip point. So if you reduce your gain or reduce the subwoofer level so the amplifier amplitude on the sine wave is not reaching its clip point, then you'll be doing less power. And remember, subwoofer loads are reactive loads. So even if you have your amplifier, your 5k amplifier,